Good day! I'm Arvin Enriquez, your subject teacher for Probability and Statistics. With this video lesson, we're going to discuss the topics illustrating bivariate data and constructing a scatter plot. Our lesson objectives: at the end of this lesson, you are expected to illustrate the nature of a bivariate data, constructs a scatter plot, describes shape or form, trend or direction, and variation or strength based on a scatter plot. So let's deal now with the nature of bivariate data. So before moving forward with the formal discussion of this nature of a bivariate data, let's have some review about the terms that we discussed from our previous video lesson. First term, so data. So when we say data, these are individual pieces of factual information. So when we say factual information, it is an information that is solely deals with facts and used for the purpose of analysis. So these are data that we gather from our survey, from our questionnaire, from our checklist, no? These are raw data from our respondents, no, in our research. It is the raw information from which statistics are created. So from the data that we gathered, no, from our survey, from our questionnaire, from our checklist, then from that, we can really assess and we can really check if our assumptions are acceptable or not. So this data will serve as our basis, no, the result from the computation in the test statistics based from this data that we gathered, then that's the time that we can decide whether we accept or not your assumptions. Second is your statistics. So are the result of the data analysis, its interpretation and presentation. So from the test statistic, we need to interpret the data that we gathered from your research and using some graphs, for example, normal curve, so we can easily visualize what are the behaviors, no, of this data. So we can easily, for example, if we're dealing with the score of the student, no, in their fourth quarter exam, then how many students are belong to the below average? How many students are belong to the above average? So using the concept of this statistics right after the interpretation, we can present these data or these computed values, no, using your uh, normal curve for us to visualize more, no, and from that we can arrive or we can conclude. So in other words, some computation has taken place that provides some understanding of what the data means. Statistics are often, though they don't have to be, presented in the form of a table, chart, or graph. That's why we simply use a normal curve for us to present your C value, your T value, your C and T critical values, your rejection region, your non-rejection region, for us to see or for us to visualize easily, no, if we can reject or we can accept your null hypothesis. So let's try to deal with this figure that will represent, no, your correlation and regression analysis. So from this part, there is a phrase here. So when we say healthy students are better students, are you saying that the academic performance of a student depends on his health? So we can say that healthy students are better students, but not all the time. It doesn't mean that that the student or the students are healthy. It's automatic that they are performing student. So there are times that even they are not healthy, they are performing students. So somehow, no, the health of student or the academic performance of the student, will be dependent on his or her health, but not a 100% or not totally dependent on his or her health. So there are times, no, again, there are times that a student or students are performing, but there are no lapses in their health. But most probably, no, a healthy student are performing student because there is a relation, no, the way we think, the way the way our brain, no, process, no, what we study, what we learn, no, some there is a relation, no, from our health. So if there is a lapses on our health, no, there is an effect the way our brain function. Now let's move forward. So based on the health and the academic performance of the student, definitely there is a significant relationship, no, between these two variables. The academic performance is will be it can be dependent, no, on the health of our student, but not all the time. But because there are times, no, even if there are lapses in the health of the students, still they are performing. But most probably, once a student is healthy, then he or she will perform well in the class. So for the next statement, for instance, no, how does your daily allowance as a student affect your grades? How does the weight of a student compared with his or her height? How does poverty affect the number of crimes in particular region? So there is a significant, no, as we can see, there is a correlation between these two uh, variables. For example, the daily allowance and the grades of the student. So definitely there is a relation, no, between the grades of the student. Why? Because with the daily allowance, it really affects, no, uh, their meal, uh, the way they fast their projects, uh, the way they go to school, no, it really affects. Why? Even if there is a minimal, no, issues, no, with their meals, with their transportation fees, no, still there is an effect to the grades of the student. So how does the weight of student compare with his or her height? So when the height of the student increases, no, it's automatic the weight of the student also increases. But it doesn't mean when the weight of the student increases, the height also increases. So we need to see those things, no? But there is an existing relationship between these two variables. With this poverty, the level of poverty and the number of crimes, so If the poverty level no in a particular place or in a particular region increases, most probably people will do something bad because they need to survive. That's why when the poverty level increases, most probably the number of crimes also increases because people, it's a natural instinct no for people no that they need to do something no for them to survive. That's why they attempt to do something bad. They commit crimes or they deal with some illegal works no because of the poverty existing. But it doesn't mean no when the number of crimes increases, the poverty level also increases. But still there is an existing uh, relationship no between these two variables. So with this figure here, monthly sales uh, with respect to the profit of the company. So for example, so if you know the monthly net profit of a company for a period of time, can you predict its net profit for the coming months? So yes, we can predict the profit of the coming months because uh, we have basis I mean from the previous month. So if you try to assess the profits of the company from the previous month, we can use this data for us to predict the profit of the company for the coming month. So there is a significant relationship between the previous profit and the incoming profit of a company. So when one applies for a job, what requirements are needed for submission? Let's deal with this figure. Why are they required? So can a hiring officer predict the kind of workers and applicants will be based on the submitted requirements? So with our resume, so partially the hiring officer can predict what kind of worker or uh, an applicant will be based on his or her resume because in a resume there inputs personal informations or are included. For example, our educational background, our special skills, trainings and seminars that we attended and most probably those are organizations that we continuously dealing with. So based on our resume or based on the inputs included on our resume, the hiring officer can predict what type of applicant or workers this person by simply looking or by simply assessing the informations included in his or her resume. So these are some if someone asks you what are the real life application of this correlation and regression analysis. So these are some of real life situations that requires decision making that will be discussed in this video lesson. So with this lesson, no, we will learn how to determine whether there is a relationship between the two variables using correlation analysis. We will also learn how to predict the value of one variable in terms of the other variable using regression analysis. So you need to take note of this, no, with this video lesson, or from this video lesson. This will be the start up to the next video lesson. No, we're going to discuss, no, how to determine whether uh, there is a relationship between the two variables uh, involved using the correlation analysis. And at the same time, we're going to use the regression analysis for us to predict the value, no, of one variable in terms of the other variable. So from our discussion proper, so the data in statistics is sometimes classified according to how many variables are in a particular study. So it can be one variable, two variables, or more. No, it depends on the given research that we're going to deal with. So for example, height might be one variable and weight might be another variable. So depending on the number of variables being looked at, the data might be univariate or it might be bivariate. No. So univariate, once you are dealing with only one variable, no. Bivariate, once you are dealing with two variables, no. So there is an involvement of your two variables. So for us to uh, understand what is a bivariate data, so this will be your formal definition of a bivariate data. So a bivariate data consists of two numerical or quantitative variables. So thus, a bivariate analysis means the analysis of bivariate data, it seeks to find the relationship between two sets of values. No? So a bivariate data, no, once you are dealing with the bivariate data, so there is an involvement of two variables as compared, no, to your univariate data, that there is an involvement only of a single variable. So in a univariate data, no, I want you to take note of this. No, in a univariate data, the major purpose of analysis is to describe, no, based on the descriptive statistics computed, no, such as, for example, so averages, so standard deviation, frequency counts, and etc. and the likes, no. While in a bivariate data, the purpose of analysis is to describe relationships where new statistical methods, no, will be introduced. We will be describing relationships, no, between related variables in terms of strength and direction. So, for example, no, there are lots of examples of bivariate data. So, for example, um, in a class, IQ scores and math scores in a long exam can be collected. So, in chemistry, so for example, a confined gas can have different volumes and corresponding pressure. In physics, no, an elastic spring can be subjected to varying stress, which will be accompanied by the corresponding elongation or strain. So in motoring, we can collect from different cars their ages and their mileage. So with these given examples, no, in every example, there's a given two variables involved that we can check and we can assess if there's an existing relationship between these two variables involved, no, in every examples that I mentioned. So, no, IQ scores are related to scores in math. No, most probably, an IQ score defines the intelligence of a student. More often than not, intelligent student will perform better in mathematics. No, definitely, no. Intelligent student will perform better in mathematics. Thus, no, we can conclude that the higher the IQ of a student is, the higher his or her math score will be. On the other hand, mileage and age of the car are related in a different way. The older the car is, the lesser its mileage. Because the mileage will represent the life, no, of your car. With this slide, there are given illustrative examples now based on your modules, no. So I already gave you the different example for the bivariate data. So let's try to discuss more what is bivariate data using this illustrative example, no, based on your modules, or these are examples included in your modules. So how does the daily allowance, no, of a student affect their grades? Yes, definitely, no, because if the allowance of the student is only for his or her transportation fee, then how about his meals, no, for recess, for lunch, for the afternoon break, no, and how about the allowance for the project, no? It If there is a small amount of allowance, no, being given to the students, so there's an effect. It really affects, no, the grades of the student. For example, no, if his or her allowance is only for the transportation fee, if the teachers gave uh, the students, no, a project, for example, so he or she could not pass, no, on time. Why? Because his allowance, no, is only for transportation fee. So meaning to say that there is an effect, no, once there's a small amount of allowance being given to the student, he or she can pass, no, his outputs on time. That's why his or her grades are affected. For number two, how does the weight of student compare with their height? No, most of the time when the height of the students increases, no, it's automatic their weight also increases. But there are times where your weight increases, then your height does not increase. So meaning to say at some point, no, your the value of the height, no, will be I mean the value of the weight will be dependent on the height. But there are times wherein the value of the height, no, the value of the weight is not dependent, no, on the height. It doesn't mean when your height increases, your height also increases, no. But most probably, no, when your height increases, your weight also increases. So still there is a significant no, relationship between these two variables. So there is an independent variables. For number three, poverty level and number of crimes, no. In a particular region, for example, I said a while ago, no, when the number of crimes increases, most probably, uh, I mean, when the poverty level increases, so most probably the number of crimes increases because people needs to survive. So even if an activities are illegal, no, because of they really need to survive, they really need to find food for foods and money for their family to survive too. They uh, they commit, no, they really or they deal with illegal works, they bad activities, no, that might affect, no, the lives of other people. But as a person, no, as a family, so that needs to survive, then even if that is illegal activities or illegal works, no, At some point, we decide no to do this, to deal with this. That's why when the poverty level increases, no, most probably the number of crimes also increases in a particular region. But it doesn't mean when the number of crimes are increases, no, the poverty level also increases. So it can be there is still no the involvement of independent and dependent variable. So let's deal now with the types of a bivariate data analysis. So the first one is the scatter plot. So we define your scatter plot as it is a chart that shows several different types of relationships between your two variables. No, so scatter plots. So these are two words. No, but sometimes written no as one word. So scatter plot. No, it can be written in one word, and it's also called scatter graph, no, or scatter diagram. So there are terms, no, or other terms for this scatter plot. So it can be scatter graph or scatter diagram. So when you hear scatter graph or scatter diagram, it's automatic. It's the same thing with your scatter plot. So you need to take note of that. So a scatter plot no shows no how each point collected no from a set of bivariate data are scattered on the Cartesian plane. So it gives a good visual a picture of the two variables, which helps in finding the relationship no that exists between the two variables. So a scatter plot is a graphical representation of the relationship between two variables because using your Cartesian plane, so we're going to assign your y-axis for a certain variable, for example, height. So we put height to your y-axis and your weight to your uh, x-axis. So by simply using your Cartesian plane and by simply putting or plotting no a point no because there in every height there's a corresponding weight. So if we plot this data no to our Cartesian plane, we can easily visualize if there is a significant relationship between these two variables involved because we can see the behavior of uh, the dots no that we plot no based on the data that we gathered from your height and weight no from our research. For number two, your correlation coefficient. So it is a statistical method no used to determine whether there exists a relationship or association between your two variables. So here to our next video lesson, there are values for this correlation coefficient, or there is a range no values, and there is a descriptive term no for each of the range that we're going to discuss. So there's a typographical error here. So double F for your coefficients. So you need to erase one of your F here. The third one is the regression analysis. So it is a statistical method used to describe the nature of relationship between the two variables that is can be positive, negative, linear, or non-linear relationship. So here, no, you can describe, no, this regression analysis. You can actually describe the nature of the relationship between your two variables. So there are positive, negative, linear, or non-linear relationship. So to our next slide, or to then we can discuss more about this, regression analysis and the positive, the negative, the linear, and the non-linear relationship between the two variables involved. So, for example, if a researcher wishes to see whether there is a relationship between the number of hours students studied their lesson and their test scores in an exam, Then the researcher selects a random sample of students, determine the hours studied, and obtain their uh, grades in the exam. No, so there's a typographical here. No, so in this table you can see the student. There's a student A, B, C, D, E, and F, and the second column will represent the number of hours in studying. That will be 621523, and the grades 82, 63, 57, 88, 68, and 75. No, as you can see in your student 6, no, if we try to observe the data that's being given, no, then this will be the highest value for the number of hours in studying. And for the grades, no, grades in percent, so 88 will be the highest, highest grade, no, for student D. But if you try to look at this one, no, the trend for this one, um this 5, no, 5, your student D only study his lesson, no, in only 5 hours, but he got the highest grade, which is 88, while your student A, no, puts a lot of time more, an hour, no, more than the student D, but he only got an 82 as his or her grade, no, which is lower than 88 from student D. But for let's try to look at your student B and student E. They have the same hours, no, uh, that they put, no, in studying, the same 2 hours, but the outputs, no, of student E is only 68, higher of 5 points away, no, from your student B, but they have the same number of hours put, no, in studying. In student F, no, 3 hours for a 75 grade, no. As you can see, no, at first, no, you don't even visualize that there is a significant relationship, no, in studying, no, hours in studying and uh, the outputs or the grade, no, being provided by the outputs of the students, no. We can say that if the number of hours in studying increases, the grades also increases, because there are cases, no, wherein even if there is a small amount of hours that we put on studying, but still some of the student can get no, a higher grade compared to those students who spent more times, no, in studying. That's why, so at some point, no, most probably, no, most of the time, when the number of hours in study increases, most probably, most that we can apply, from to our student, most probably if the number of hours in study increases, then their grades also increases. But there are times, no, from this scenario, that we select a random sample of students, no, that we subject for our research, and we wanted to look, no, for a significant relationships, no, between your hours of studying and the grade, no, of our student. But based on the table, no, we cannot predict, no, I mean, so the sequence of the number of hours and the number of grades, ano, so there is a uh, different variations of grade, different variation of number of hours studying, but we can actually see this one, or we can visualize this one using the concept of your scatter plot. If we're going to plot this one, we can see the behavior of the number of R's, no, if that is a negative or uh, positive correlation, or it can be zero correlation, no. So there are possibilities that even if we select a random sample of student, we can still arrive to a zero correlation, meaning say that there is no significant relationship between your two variables involved. But it can be also a positive and negative correlation. So for us to visualize, no, kasi at first, no, based on the table, we cannot visualize that, or we cannot conclude that if the number of hours in study increases, the grade also increases. I mean, no. But using the concept of your scatter plot, we can determine the direction, the strength, no, or what type of correlation is this one? Is it positive, negative, or zero correlation? So using your scatter plot, we can visualize this if there is a significant relationship, no, between these two variables involved. So the two variables for this study are called the independent variable and the dependent variable. So the independent variable is the variable in regression that can be controlled or manipulated. So we can control and manipulate your independent variable. So it is sometimes referred to as explanatory variable or predictor variable because we can control and manipulate this one. So if we manipulate and control this one, we can replace one variable to another variable and make this conclusion, or make this final decision an ideal decision, no, based on our computations. So in this case, the variable number of hours studied is the independent variable. So we can manipulate and control this number of hours studied, and is designated as x. So we use x variable to represent the number of hours. So the dependent variable is the variable in regression that is assumed to be affected by the independent variable. Yes, it is, no, because your grade will always depend on the number of hours we studied. If the number of hours is your independent variable, and then the grade is the dependent variable. So the dependent variable is sometimes termed as the response variable. So you need to take note of this. The grade the student receive in an exam is a dependent variable designated as y. So we use variable y to represent the grades of the students. So the reason for this distinction among the variables is the assumption that the grade of a student, so there's a typographical here, and depends on the number of hours the student studied. Also, one assumes that to some extent, the student can regulate or control the number of hours to study for the exam. So, the grades will not entirely dependent, no, on the number of hours, no, that a student put in their study. So let's deal now with your scatter plot. So one way to analyze the bivariate data is through a scatter plot. So a scatter plot, so there are terms, no, or other terms for this one. Scatter plot, it can be one word, no. A while ago we mentioned this one. So scatter graph, scatter chart, scattergram, or scatter diagram. So these are terms, no, that we can use to, or as a replacement for the term scatter plot. So is a type of flat or mathematical diagram using Cartesian coordinates to display values for two variables in a set of data. So we usually use your scatter plot, no, for us to see, no, the behavior of the two variables involved, because using your Cartesian plane with the x and y axis, we can actually visualize, no, the behavior of the data or the variables being involved, no, in a certain problem or is in a certain research, no, that we are dealing with. So for us to visualize more what is scatter plots, no, let's try to discuss. So let's move forward with the formal discussion of these scatter plot. So scatter plots are similar to a line graphs. So a line graph uses a line on an x and y axis to plot a continuous function, while a scatter plot uses dots to represent individual pieces of data. In statistics, these plots are useful to see if two variables are related to each other. It gives a visual idea of what is happening with the data. So for example number one, no, construct a scatter plot for the data obtained by the manager of ABC system in a study of age and systolic blood pressure. So we're dealing with the systolic blood pressure, no, of a random selected sales representative. The data are shown in the following chart. So in your first column, these are the sales representative A to F and their corresponding age in your second column and the corresponding systolic blood pressure in the third column. Now, what is systolic blood pressure? So for example, 120 over 80 mm of mercury, no? So the top number refers to the amount of pressure if your arteries during, no, the contraction of your heart muscle. So this is called systolic pressure. The bottom number refers to your blood pressure when your heart muscle is between beats. So this is a called diastolic pressure. So your systolic pressure is your 120, so that will be your systolic pressure, and the blood pressure is your 80. So this one, no, will represent your diastolic pressure. So for steps to construct a scatter plot, so step number one, draw a label that x and y axis as shown in the figure one. So you need to deal with your how you draw your Cartesian plane. So you need to review how to deal with your Cartesian plane, how to draw a Cartesian plane, and how we put the values for your x and y axis that will represent the two variables being involved. So step number two, plot each point on the graph as shown in figure 2. So with the given values, we just simply plot, no, the given values on this ca- Cartesian plane, or for us to see what is a scatter plot, no. So in figure 2, we just we are just plot with respect to the x and y variables not being involved in the age and the blood, the systolic pressure of the given sales representative. So this will be your figure number 2 here, because we use variable x to represent the age and y for the blood pressure. I mean, we use y variables, no. So there's an error, no. So we use variable y, no, to represent the pressure and x for the age. So in every age, there's corresponding blood pressure for the individual, no. That's why we can input this one by using your Cartesian plane. So for us to visualize the behavior of this plot, no, what will be the behavior of this plot? At some point, the age, no, when the age increases, then the blood pressure also increases. But there are some point here when your age increases, then your blood pressure also increases. So we need to look for this one for us to visualize, no, what are the possible conclusions, no, possible correct conclusions, no, based on this scatter plot. So interpreting the scatter diagram. So a scatter plot shows the type of relation that exists between two variables. So it aims to distinguish scatter plots that simply a linear relation from those which simply a nonlinear relation. And from those which imply to no relationship, it describes association of variables according to. For number one, form is the association linear or non-linear? So when we say linear, when the points closely resemble a straight line or when a variable increased by approximately the same rate as the or other no variable changes by 1 unit. As you can see on this one in your linear equation using this figure number one here, no, that's why it is called linear relationship because we use line no for us to visualize the relationship between your two variables. That's why it's linear relationship. While the curvilinear relationship, when the points has a form of curvature rather than a straight line, when one variable does not increase at a constant rate and may decrease at a certain point. Now, at some point here, no, when your x increases, at some point here, uh, your y variable retain no to its maximum value here and increase and decreases at some point here. So there's a curve no being uh, used no in this one to represent the relationship between your two variables involved. We can say these are curvilinear relationship in a way that this is not a straight line because at some point no your one variable or your dependent variable decreases no as you can see in this one, even if your x increases at some point here, no, your y decreases. So that's a curvilinear relationship between your two variables involved. So let's deal now with the direction. Is the association positive or negative? So two variables have positive association when the above average values of one tends to accompany above average values of the other, and when below average values tend to occur together. Then the two variables have negative association when above average no values of the 10 accompanied below the average value of the other. As you can see here, no, so this line, no, if you try to look at this line, so this line make a 45 degrees, no, with your x and y axis, meaning to say that the equation of this line is equal to x is equal to y, meaning to say in every point that will fall, no, in this line, every point has a horizontal and vertical distance no in your x and y axis. So whatever the value of the horizontal distance of a point no that will fall here will be equal to the vertical distance no from of this point to the x axis. Meaning to say if we consider this point no, so the vertical distance of this point to your x axis will be equal to the horizontal distance of this point to the y-axis. Because this line, as you can see, this line no, makes a 45 degrees to your x and 45 degrees base to your y. No, why is it positive linear association? Let's try to go back with the concept of your lines no, in your analytic geometry. In your analytic geometry, we say that if your uh, if your line no if your line or the slope of the line no is a positive, then your line uh if your m is positive, then your line rises from left to right. Same thing with this one no, it is positive linear association in a way that the line no rises from left to right. So that will be the direction of the line. Now, for us to visualize more, no, what is a positive linear association? For this graph, as you can see, lower value of y can be mapped to lower value of x. A higher value of y can be mapped to a higher value of x. So meaning to say, a lower value of y can be mapped to a lower value of x, or a higher value, no, of y can be mapped to a higher value of x. As you can see in this figure, no, a lower value of y can be mapped to a lower value of x. A higher value of x can be mapped to a higher value of y. So if we consider this intersection, no, of a vertical and horizontal line from your x and y axis, a point will fall on your line. And you say a lower value of y can provide you a lower value of x, a lower value of y can provide you a higher value of y can provide you higher value of x, or vice versa. So that will be a positive linear association. Now, dealing with your negative linear association, in your analytic geometry, when your slope is a -1, then your line falls from left to right. So as you can see, no, in this figure, your line falls from left to right. So the direction of your line falls from left to right. Now, for this one, no, it's different. A higher value of y can be mapped to a lower value of x, then a lower value of y can be mapped to a higher value of x. So again, a higher value, no? Higher value of y can be mapped to a lower value of x, and lower value of y can be mapped to a higher value of x based on the negative linear association. And once your slope is a negative value, then your line falls from left to right. So for your activity, so in analysis of a scatter plot, what two elements should be considered? So you need to list down and explain. For number two, what explains the strength of correlation between two variables? So this will serve as your short quiz for this video lesson. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. I'm Marvin Enriquez, your subject teacher for probability and statistics.